Looks good. Hold on online, we're fixing the slides.
Are we having cyber infrastructure problems, Gautam? Are we having cyber infrastructure problems?
Oh, minor ones, yes. Let's make it full screen first. Hopefully. Switch to Zoom. Share screen. And hopefully share that.
It's good.
That's just the pointer. And give me just a second to hide the little Zoom thing there. And you're off.
Okay, so I'd like to thank the organisers for inviting us to give a talk and for laying on such a splendid meeting. I'd like to thank the audience for still being awake at the beginning of the cyber infrastructure talk. I'm Adam Brazier. I work at Cornell. I'm the chief architect for SCiMMA, and I also work in Nanograv, although that won't be relevant to this talk. My co-presenter is Bryce Cousins.
Yeah, I'm Bryce. I'm currently right now a software developer and researcher with LIGO at Penn State, but I'm an incoming first-year grad student here in the physics department.
So we're very sad to see Bryce go, but he's done some really good work while he's been in SCiMMA right since the beginning of us constructing anything. Okay.
It's only for the cyber infrastructure talks that we.
Yeah. We laid this on especially. Okay.
That seems to be right.
Arrow keys. Okay. So the talk is about how we're going to connect LVK O4 alerts to Rubin's auxiliary telescope to drive target of opportunity observations. I will start off talking a general overview of SCiMMA and the technical components we've built. And then Bryce will take over. He will talk exactly how this project is working with Rubin and LVK and give a quick demo of the prototype. Then I'll jump back up at the end and give a summary and talk a little bit about how you can get involved. So scalable cyber infrastructure for multi-messenger astrophysics is both our name and our game. We arose from a conceptualization exercise within the community funded by National Science Foundation, which included a large number of scientists, including our session chair, Federica Bianco. I haven't forgotten. And in this room, we have Gautam Narayan, Andy Howell, and Curtis McCulley, in addition to Bryce and myself, who are all active participants in SCiMMA. There are 10 institutions listed up there who are part of our funded group on our current NSF grant. But if you look at the people page, you'll see that there are many more people involved. What we have built that is relevant to this talk today, we've built something called HOPSKOTCH, about which you've heard already, a pub subserver. We've got a federated identity and access management system, and we've got a Python client, which is integrated with the IAM system, and which speaks both to and from the HOPSKOTCH server. And I'll give a little bit of an overview about those, and then you'll see how they're used in operation when Bryce is talking. So thanks to Andy Howell for indelibly putting in my mind this visualization of how multi-messenger astrophysics follow-up often works in practice. We would like a bit less of this, and we would rather be this, the most interesting astronomer in the world. Now, you may remember earlier on, Andy gave a schematic that included an adorably confused dog about how things can work in practice. We would rather it worked a bit like this. An alert comes in, see if I can see it. Alert comes in, telescopes spring into action, data are taken, the data are reduced, they're made available to all the people who have permissions to see it, and then machines and humans make inference. And then, depending on the outcome of that, the whole thing starts again. So this here is an excellent place for you to be using a TON that Curtis spoke about yesterday. And here, this is very conveniently mediated by Hermes that Andy spoke about a little under 3 hours ago. And you'll see all these arrows. You can imagine there's a great deal of communication going on here. And that's what SCiMMA is focusing on, is enabling all of this communication. So our principles are based on community involvement. We arose from a community conceptualization exercise. Our development is all open source. I'll say where you can get access to it towards the end. We try and use existing tools where possible. We don't want to re-engineer any wheels, particularly including sort of NSF-funded cyber infrastructure that's been built for scientific research. And we use an Agile Scrum distributed model for software development. So far then, when we analysed the needs to make that happy path happen from earlier on, we realised that we needed a pub subservice, we needed an easily installable Python library/client that you could use to access it, and we needed identity and access management designed in from the beginning because of the needs of proprietary astronomical data. So what we did was we built the pub subsystem we call HOPSKOTCH. You've heard about it already a little bit. We built the client, we call it Hop Client. You can install it very easily from Conda and pip. It's documented on Read the Docs. It wraps and adds extra features to the very performant client software written in C and C++, which accesses the pub sub underlying system, which is Apache Kafka. And then our IAM system is based on CI logon and co-manage. So this is a model of what might happen relevant to this particular talk today if the source of the alert was LVK. It doesn't have to be LVK, as Andy pointed out. It doesn't have to be any sort of multi-messenger astrophysics at all, really. It can be any time domain science, time domain astronomy. It's actually also been used by one of our members for Internet of Things agricultural sensing. So the message goes into HOPSKOTCH via a communication channel. In the architecture we have, that's called a topic. And anyone who is subscribed to the topic will get that alert. So it's a one-to-many relationship here. Then telescopes spring into action, the astronomers spring into action. More communication can take place via HOPSKOTCH, all with very, very low latency. The actual latency inside HOPSKOTCH is very, very small. It's dominated by the internet communication time. And as Andy and Curtis both spoke about in the last 2 days, these observatories can be coordinated via TOMS, and Hermes can vastly simplify the activity of the astronomers by providing an interface to all of this. And then all this communication still happens over HOPSKOTCH very, very quickly. So what PubSub is, you can think of it essentially, each topic, each channel, is basically like a big log file. Publishers add to it at one end, and then when you connect, you get whatever it was that you didn't already have. Okay? And in the MMA follow-up model, we would expect people to be connected all of the time, but if they weren't, they would get it when they connected. The LVK low latency requirements insist on, which are public, insist on less than 1 second of additional latency, and with the HOPSKOTCH time and with the internet time in our tests, we easily meet that. As I said, the PubSub channels are called topics, but most importantly, the IAM control happens at the topic level. If you have permission to connect to a topic, you can get the data which go through that topic, but there's no obvious limit on the number of topics. You can have thousands, tens of thousands, and more on the PubSub system. So, Mario Juric put this slide together after being repeatedly asked whether or not HOPSKOTCH was doing the same thing as an LSST broker, and it's not. We're not gluing ourselves to the LSST fire hose. The brokers have been worked on for a long time, and built some really excellent systems for that. In the context of this talk, we are upstream of Rubin, and we will be sending LVK alerts to Rubin. LSST brokers, of course, can subscribe to channels, get alerts, perform enhancement, and then send back enriched messages via HOPSKOTCH. We are going to build, Andy mentioned this earlier on, a queryable archive. I'll talk more about this later on, but brokers can also do correlations with the historical data. And then lastly, we're a technology provider. We are building and maintaining all of the streaming technology, and we will also provide consulting. Okay. So, the server itself, HOPSKOTCH, which started off as a tortured acronym, and I think Andy vetoed that, but we kept it called HOPSKOTCH. The scaling behavior we can get from this is easily over 100,000 messages per second without any tuning at all. And it's well known that Kafka can go to 1 million messages per second. But obviously, if the messages are very large, then there will be some impact. And we've done an industry standard deployment. Kafka is a commonly used tool in industry. We've deployed it in AWS. We have a plugin that deals with the IAM. And although it'll take all data formats, so you can send your images, you can send your FITS files, whatever you want, the client currently has special support for JSON and Avro, which are convenience features, but also once we've built that MMA archive, it'll be easier for us to pass some information out of it. Oh. Okay. The HOP client, you can either use this as a command line client, or you can use this as an API, essentially a library that you import into your Python code, or you can extend it using the template we provide on GitHub. And there's a tutorial and a demo at that link there, so when you get the presentation, you'll be able to click on that. It integrates with the SCiMMA IAM system, which I'll be talking about a little bit in a second. And an extra feature we've added, which was particularly desirable, is a robust mode where if your connection as a publisher goes down to the server, which often this can happen, particularly if you're an observatory, then the messages will be cached locally, and the client will keep trying to re-establish the connection, and when it re-establishes the connection, it will send all of those messages. So you won't lose anything. There'll be a delay, but that delay is caused by the internet, not by the software. Now, if you're like me, you think of IAM as a long, dark winter of the soul, but it's necessary, and we have built this system which will allow you to secure proprietary access to your data. Like Andy said earlier on, SNEWS are using this already. I'll talk about them a little bit in a moment. There's a web application and an API for it called SCiMMA Admin. That's where you can give permissions, revoke permissions, and you groups of people together with the same permission. And you can also grab application tokens which you put into the HOP client so that it can access the topics to which you have permission. Currently, we're building the last few convenience features for this. We've got about 130 users at the moment, and based on our experience of onboarding them, there's a few things that we want to fix. We're targeting early September for it to be ready for mass onboarding, and I was at the sprint review earlier on this morning, and everything looks good for that date. Okay, this is my last slide before I hand over to Bryce. Andy showed you Hermes earlier on. I don't need to say much more about it, apart from it's a really convenient way for astronomers to do their part of multi-messenger follow-up. LVK Low Latency Group has adopted HOPSKOTCH for internal use, as well as the planned external alerts to be sent through it in O4, and also Ammon and IceCube are integrated with HOPSKOTCH. IceCube at the moment is sending a position scrambled stream of their real data, but they will be sending the actual with correct positions soon. Bryce led from our side a collaboration with the Supernova early warning system very early on in our technical development. That was very successful, and they are now using it because they wanted to upgrade their communications fabric to a second generation. It went so well, in fact, that Bryce and Amanda Baxter led the writing of Amanda Baxter's from the SNEWS side, led the writing of a paper which we learned, I think, at 5 a.m. this morning, has been published in the Wiley Journal, Software Practice and Experience. And now I will hand over to you to talk about that last bullet.
Great, thanks, Adam. Yeah, so as Adam mentioned, SCiMMA is focused on both all this technology development, but as we've put in a lot of effort to try and reach the community and help them not just, say, here's our code base, go install it. We've done some active collaborations, particularly with SNEWS, but now more recently with Rubin, to try and get those tools adopted. So this is just a diagram from this newspaper, but it gives a good outline of our vision, at least, as SCiMMA, of how we have our technologies integrated into the community. So we have HOPSKOTCH and HOP Client all in blue. This is just what we're providing. We envision it as a platform for triggering observatories or external alert systems like GCN to send messages to, and that individual users, astronomers, full detector networks, or follow-up observatories will be able to utilize through subscribing. And in practice, it ends up looking pretty similar to our vision. There's a range from very simple integrations that we've done with the community to very involved. Most simply is with GCN. That's not even a collaboration, it's just a relay of their WebSocket alert stream as a pass-through into HOPSKOTCH. We're not doing anything special with parsing or reformatting or doing anything with those messages. We're just passing through. you can get GCNs through other means, but this is just to provide those alerts alongside the other topics that we have in HOPSKOTCH that you can access just the same instead of waiting for an email from GCN. You can get it through a integrated API. We've hooked up LIGO Virgo Kagura users as well as IceCube. We've done some onboarding with them to bring them into HOPSKOTCH. We've created user groups for them. Both IceCube and LVK are using HOPSKOTCH topics mostly for internal development to do prototyping for their own observing runs, but some of them are public, like Adam mentioned. IceCube is sending out a scrambled alert stream just for the sake of downstream applications being able to prototype against HOPSKOTCH. We've also integrated with 2 detector networks so far. AMON, the Astrophysical Multi-Messenger Observatory Network, that's a multi-institution initiative led at Penn State that integrates a lot of ground-based and space-based detectors and observatories with some just public data, but as well as MOU for sub-threshold data that they then consolidate, run some coincidence checking, and seeing if there's anything interesting possibly happening in the same point in the sky. And then they send out an alert. We have a stream on HOPSKOTCH for those alerts specifically. Those are publicly available, so that's something you can use HopClient to connect to. And as Adam mentioned, we also have a much more substantial collaboration with SNOOS that was several months back in 2020 into 2021, where we pretty much built out their entire platform for their next generation of neutrino detector network. So they're trying to detect the next galactic supernova, and there's, I think, around 10 neutrino detectors that they onboarded using HopClient, custom template client, and HOPSKOTCH accounts. So we did a lot of integration with them. But of course, this is a Rubin talk, so what's most interesting and most recent over the past month, we've been doing a focused collaboration with the Rubin team in conjunction with LIGO to try and figure out how we can do target of opportunity follow-up in an automated fashion during 04, 05, and LSST. So that's going to be the focus of the rest of this, where we're creating a collaboration with LVK, SCiMMA, and Rubin. The goal of which is to do target of opportunity for gravitational wave events. We've heard a lot about the science case for this from Andy. As a reminder, GW sources will have transient EM counterparts that Rubin will be able to detect. There's a lot of science cases. We know that kilinovae come from binary neutron star mergers. We know there's several known unknown sources that we expect to get from other kinds of mergers. And tons of science cases. When I'm not doing software development for SCiMMA, I'm trying to use binary neutron stars to measure H0 and do cosmology. And so I want these systems to work end to end so that we can get that, luminosity distance measurement as soon as possible, because we may miss out. Because the follow-up needs to be really pretty prompt. Light curves decay pretty quickly. And so what we're trying to do is use target of opportunity time during LSST. There's been projections in this paper here that say, no more than 2% of LSST time would be able to be committed. So that's less than 100 hours per year of LSST. So any pipeline that we're going to be doing for TOOs needs to be rapid and prompt and ideally automated. And so what we're doing in this prototype is trying to receive a gravitational wave alert from the LVK, throw it through a pipeline so that we can have a pointing and slewing to the sky. So that's the goal, and so far we've presented this idea to LVK and Rubin. We've gotten backing from the spokesperson of LIGO and of Rubin to try and get this project off the ground. We've developed some systems in SCiMMA. We already had onboarded LVK users last year, so they already have a lot of testing infrastructure, alert streams built in on HOPSKOTCH. We recently got Rubin onboarded as well, where we've created a group as well as some topics. This is just the user interface for HOPSKOTCH topics. So we've built up a lot in SCiMMA. We've also started coordinating with Rubin. They have a system that's going to be very important in this prototype called the Auxiliary Telescope, Auxtel. Auxtel, I wasn't aware of it until this collaboration, actually. It's not built for the prototype, obviously. It's going to be a 1.2 meter telescope that's going to do spectroscopic observations to complement LSST to do help with photometric calibration. But what makes it really useful for this prototype pipeline is that it's running the exact same scheduler, systems, software stack as the main telescope will be in LSST. So it's the perfect system to be prototyping against, since anything that works, in principle at least, with the Auxtel will be able to be plugged into the main telescope during LSST. And this will let us plug into the observing runs really quickly. It's already starting doing mock runs twice a month, and this will help with prototyping during the next observing run 04 for LIGO before Rubin comes online. And so what this looks like as a quick overview, I'll go through this quickly. We have several steps involved. We're going from the LVK with their alerts being sent to HOPSKOTCH, using a custom client that we've been developing to parse those alerts and do some schema reformatting, since we need Avro for this in particular, pushing those over to a database that is then going to be accessible by the Auxtel scheduler. And this has all been done by me and Tiago Ribeiro. He's a programmer on the Telescope Insight team and has been essential in getting this prototype where it is. So in practice, we have the first 4 pieces of this in place, at least in a prototyping stage. It's undergoing active development as of today, so there's still a lot of pieces up in the air, but we've managed to get things pretty far along. We're negotiating access to those internal alerts on HOPSKOTCH that LVK has. For the meantime, we're just doing mock alerts that we're sending manually ourselves to HOPSKOTCH. We have a Telescope Insight Hop client, which is built in some subscribing, schema parsing, and then publishing mechanisms to connect it to a Rubin-hosted database called the Engineering Facilities Database. This one's located at Tucson, not the Rubin Summit. The Rubin one is the production instance. This one is, again, an identical prototype that'll let us do some programming against to see if it'll work in production. And then the Auxtel scheduling, that's TBD. We don't have a prototype of that yet, since we don't have alerts of the right format within the EFD, but that's something that we're aiming to prototype end-to-end for an observing run this fall. And so to show this all off, this is not as a pretty demo as Andy showed earlier. This is a lot of terminals, but what we see here on the left, this is more or less an interface to HOPSKOTCH. The top is where we're going to be sending a message. Right down here, we've connected to HOPSKOTCH, and we're waiting for messages to come in. Nothing's happening since we haven't sent a message yet. On the right, we have an interface dashboard to the database hosted on Rubin. This is a Tucson hosted instance, and there's going to be a lot happening behind the screen. We send a message in, it comes into HOPSKOTCH, we see it, and then it pops on up on the database. So I'll let this play through and go again, because a lot was happening behind the scenes, but this is just a proof of concept that we can go from producing a local alert. I just pressed that button on my laptop. I was connected to HOPSKOTCH, also on my laptop, just to see that alert come through. What was happening in the background was the client doing a lot of parsing. It was also connected to HOPSKOTCH on this topic. It received that alert, did some parsing, reformatting, and then pushed it on to the database. And that's what we see here. So this is more or less just a fancy test of plumbing to make sure that things are pointing and connecting to the right things, but is a proof of concept that we've established to hopefully get ready for the next steps. The next steps of which obviously are going to be focusing on mainly these last 2 points and doing a bit more development of the client. We need to get the database integrated with real alerts so that the Auxtel can begin connecting to them, since we want to eventually do an end-to-end test where we send a replay alert from an old observing run of LVK and see what happens if we can get the Auxtel to slew. There are, of course, a few horizon-looking integrations that we're thinking about, but it's vaporware at this point since there's a lot to do before then. We obviously can integrate with other MMA systems, and this wouldn't be a boom talk if I didn't mention one of Gotham's acronyms. So I gotta say, we have Elastic. This would be a very natural plug-in, we think, to this workflow. We envision creating a mock GW alert where we create a mock GW alert that will match the properties of an Elastic transient event, use that alert to trigger the TOO, query Elastic for those event properties, and then complete the TOO slew send an alert back to HOPSKOTCH that contains information both from the TOO we just did, as well as the Elastic properties. Of course, there's a lot of other platforms that I don't have time to talk about now. This plugs in naturally to Tom's and Hermes. LCID, you'll hear about more tomorrow about Kilonova filtering from Deep tomorrow, and as well as improvements to the Auxtel scheduling algorithm to make it more intelligent given a SCiMMA alert. And with that, I'll hand back.
Okay, I'll be very quick. So if you'd like to get involved, go to our website. We have regular open Zooms where we talk about technologies and advances of interest. If you join the email forum, you will get the emails about that, but also you can see our previously recorded talks on YouTube. And then go to our GitHub organization if you want to see or work on our software. The future roadmap involves increasing integration with NASA's next generation GCN called TAC. We're working on that with them right now. There'll be a data lake of all data transiting HOPSKOTCH. You don't have to worry too much about what that is, but it's permissive on ingestion, and then you apply a schema on query time. And then further down the road, an analysis platform where you can actually run your own analyses from cloud. I'm going to skip through the summary very, very quickly because I think it's pretty simple. But what I want to say is if you would like to get involved, we would very much like you to get involved. So if you're interested in what you've heard, or if you are on a project and you think that this technology could be useful to you, please do contact us and we will work with you to make it happen. I will leave this resources page up here now. I'd like to thank Bryce for all of his work in SCiMMA, which has been incredible, and wish him all the best from all of us at SCiMMA as he moves on to being a graduate student, although I hope this is not the last time we see you. And then thank you everyone for your attention.
I see. Yeah. So that part is not built yet. I don't know the status on the Rubin side. That's pretty much all on the Rubin software stack somewhere. Tiago would know. What we're aiming for at first is just to do a basic proof of concept to point at that area of highest probability, the center of that, and then do something. But there's obviously a lot better methods than that. But that would be happening. Do I have a pointer? I do have a pointer. That would be happening at this point here, and
Very far removed from you and mostly on the telescope operators.
yeah, pretty much entirely on telescope operators. We want to have the alert have everything that Rubin needs to do their operations, SCiMMA, parsing, whatever. But we'll just give that information, and I'll collaborate with Tiago if he needs help on figuring that out, but that's mostly, I think, an R&D question for Rubin.
Yeah, I got it. It's green now. Questions? You're allowed.
Okay, so certainly this is from me with not my SCiMMA hat on, but there is now this infrastructure that we have seen over the last 3 days is ridiculously complicated. There are the broker systems, there are the TOM systems, HOPSKOTCH, all of these connected to actual telescope schedulers, through TOM toolkits and whatnot, and then on top of this you have active learning. How can we start to actually test all of these systems working end-to-end in any realistic fashion?
It's funny you should ask that. On our we just put an epic on our backlog to run some end-to-end tests that will flow the whole thing through. So at the moment, it really just is sitting in a document, but it's going to be turned into an epic during the course of the next sprint, and then we will start to do some tests. So if people again have workflows that they would like to test, they should suggest them to us, because in the end, we would like to demonstrate to you all that it can do what you need.
So is SCiMMA sending you a scrambled alert because they want to see your system before they reveal their transit? They want to see that your system works before they reveal their transits to it? Is
I can't hear you.
Is SCiMMA going to unscramble the alerts and make them public?
Oh,
soon?
Is IceCube going to? Yes, that's in their plan. I think there was just they wanted to get something done quickly before they had to get the full bureaucratic machinery into action. So they wanted to show it. But yeah, I believe, I'm not an IceCube member, but I believe in principle that is public data.
Any more questions? I think we can wrap up the day. Thank you so much for closing the conference today. And